Today we're talking about the distance formula. So the distance formula is used to find the distance or the length of a segment between 2 points in the coordinate plane. So if we have our 2 points in the coordinate plane, we are looking to find their distance, or this value here. So we can call this D for distance. And there's two ways that we can do that. First, we either need to know the ordered pairs for these two and then apply the distance formula, or we can use the Pythagorean theorem. Really, the distance formula is just an application of the Pythagorean theorem. But in order to do that, we need to know how much we have to move horizontally to get from this point to this point, and also how much we need to move vertically so that we can construct a right triangle, like so. Now, again, like I said, in order to use the Pythagorean theorem, we need to know, well, how much did I move horizontally, or what was my change in my x's? And then how much did I move vertically, or what was my change in y's? So we are going to represent that, because we don't really know it, as delta x and delta y. So delta, this is a Greek letter delta, just means the change in. So this is the change in the x coordinates and the change in the y coordinates. So if we want to find this length, we can use Pythagorean theorem, which says d squared equals the change in our x coordinates squared plus the change in our y coordinates squared. Now, this formula actually doesn't give us our distance. It gives us the distance squared. So in order to get just the distance out of this, we would have to take the square root of both sides. And in doing so, we would get the distance, and it would look something like this. D equals the square root of this quantity. So the change in x squared plus the change in y squared. Now, this formula is good if we know what this value is, and we know what this value is, because then we can just substitute those, square them, and take their square root. But if we're talking about the distance formula, we probably don't know what our change in our x's are and what the change in the y's are. We're probably given a set of ordered pairs. So let's just assign ordered pairs to each of these. And I'm actually going to use arbitrary ordered pairs so we can use this formula for any two ordered pairs. So I'm going to call this point x sub 1, y sub 1. And I'm going to call our second point x sub 2, y sub 2. So if I wanted to find the change in my x's, right? So this horizontal distance, how much I moved horizontally. Well, that's just the amount that I moved from here to here, right? This right here. So this right here, this has a value of x sub 2, and this has a value here of x sub 1. So if I wanted to find my change in my x's, well, again, we're just finding this linear distance. And if you remember, to find the linear distance, we just take the difference of our two coordinates. So it's x sub 2 minus x sub 1. And that will give me this linear distance here. And then similarly, we can find the vertical distance, this vertical linear distance, by finding the difference of our two y coordinates. So the change in y, or delta y, is just going to be the difference between our two y coordinates. So it's y sub 2 minus y sub 1. So we take our y coordinates and we subtract them. So now that we have these two sets, right, these two values, we can actually substitute them in for delta x and delta y in this here. And then that's going to give us the distance formula. D equals the square root of, so we know that delta x right here is x sub 2, so it's quantity x sub 2 minus x sub 1. That quantity is squared. And we're adding the change in y squared. So we're going to substitute. We know the change in y is y sub 2 minus y sub 1 quantity squared. So this formula here is our distance formula, and we would use it if we know the ordered pairs, and we could then just plug in the ordered pairs to find the distance.